Here's problem number 25. We're asked to find the interval of convergence for this series. And I think what's important to note here is that we've got a single thing raised to the nth power. This is going to be a geometric series. And because it's geometric and because the geometric properties are easier to work with than, let's say, the ratio test, we should do that. Let's note that this series starts with the number 1. That's what goes on when n is equal to 0. And then after that, we have root x over 2 minus 1. And then after that, root x over 2 minus 1 squared, and so on. In other words, this is a geometric series where the first term is 1, and the r value is the square root of x over 2 minus 1. Now, of course, to look for the interval of convergence for a geometric series, we'll take the absolute value of r, and we'll say, well, when is that expression less than 1? In typical fashion, we'll rewrite that as negative 1 is greater than square root of x over 2 minus 1, which is greater than 1. Let's add 1 to all of these locations, and we get that the square root of x over 2 has to be between 0 and 2, or that if we multiply everything by 2, that the square root of x is going to be between 0 and 4, or if we square everything, that x is between 0 and 16. By the way, a little note here, we know exactly what this converges to. It converges to 1 over 1 minus quantity, square root of x over 2 minus 1. And that's what I'm going to do. I'm going to actually see if we can confirm that on this interval, this series converges to that function. All right, so let's switch over to our graphing software, where I am going to graph the function. Let's see, what was it? 1 over 1 minus quantity, another fraction, and a square root of x over 2 minus 1. And then I'll hit enter, and there's our graph of that. Obviously, a lot of this graph we're not really too worried about, but if we can get it, if we can look at it between 0 and 16, which we say is the interval of convergence, that would be good. Now, what I want to do is I want to start saying, okay, well, what does the series of this look like for several terms? Or what does the Taylor polynomial for quite a few terms end up looking like? So we end up having, again, fraction square root of x over 2, and then minus 1, and we'll do it for this polynomial. And you see that, you know, it matches for a little bit, but then starts to diverge. Let's go back and add another term, and I'm going to cheat a little bit. I'm going to copy that and then say plus this quantity squared, and let's see if we get convergence for a little bit longer. Not so much. Let's add another term plus quantity. I'll paste. Didn't paste. So let me copy this and then paste it and say that this is to the third power. A little bit better. You can see it pushing up closer. Let's do it again. Quantity. Copy this. I'm going to add onto this value, but now to the fourth power. And you can see, indeed, that we are going to continue to get closer and closer, and this is pulling up. Maybe there's one more thing that we can do to make this a little bit easier, and that is I can say, you know what I really want, I'm going to get rid of all of what I had there before, and what I could say that no, I can't. What I wanted to do, well, maybe I can do this. Let's try this out. What's the worst that could happen, right? So let me add a calculator page. Let me put from the calculus menu the sum from n equal 0, and I'll say 4, and then I'll put in here that expression that we had before, and make this to the nth power. And of course, sum of, oops, try this again, have the n in the wrong place. I want that n to be on that term. Let's see, does that work? No, it moves it to the outside again. Okay, one more time. Try this. Move this to the end. I'm going to put all of that inside of parentheses. No, did not do what I needed to do. Click, click, click. Copy. Alright, this may not work at all. And I'll put to the nth power right there. Okay, there we go. So here is this expression to the nth power, and that is the cleaned up version of that. I'm going to take this expression, copy it, bring it over to here. I'll get rid of F2. I'll go ahead and put into F3, and then how about I put, instead of 4, let's put 6. Oh yes, we can see that it's getting closer. How about we put not 6 but 10. Oh yes, you can see it getting closer, and it seems reasonable that that 0 to 16 interval looks like it's happening. That at this point it's getting really, really tall, but if I go up enough, if I choose a large enough number, and of course 10 is pretty big, but you know what's bigger? 100. So let's try that. It may take a while. Oh yeah, you can see that it converges all along to 18 or to 16. So anyway, I think we've got it from 0 to 16.